Okay, so moving swiftly on, in this lecture, we're going to look at energy transfer by heat and energy transfer by work. It's going to be a really short lecture, so let's get into it. First, we're looking at energy transfer by heat. Energy transfer by heat. Okay, so the driving force is temperature difference. Intuitively, also, we know this heat is transferred from a higher to a lower temperature, so that is the driving force behind this type of energy exchange. The symbol is capital Q and it is measured in joules. Q by delta T is written as Q dot, rate of heat transfer, measured in joule per second, also known as watt. And capital Q by M is written as small q, which is heat transfer per unit mass, which is most often what I will also be doing. So I have a tendency of solving questions using per unit mass quantities, right? And in the end, I will multiply that mass. That is the approach I usually take to solve questions. However, it is totally up to you if you want to deal in full quantities. That is, you can multiply the mass as you go along. But since quantities in the thermodynamic tables are usually given as specific energy transfer, specific entropy, I tend to calculate Q in per mass terms or specific heat transfer as well. In specific heat transfer terms as well. Lastly, we have adiabatic process with delta Q equal to 0. Moving on, we have energy transfer by work. If energy crossing boundary boundary is not heat, it must be work. Closed system, remember. Because remember, only two ways of energy transfer are possible. Again, work has the symbol of W and is measured in joules. Rate of work is W dot or W by delta T. Again, joule per second or watt, because heat and work are both units of energy transfer, right? So you would expect them to have the same unit. And work per unit mass is written as this, or omega. This is omega. This is capital W. Remember, I usually tend to write it in a specific basis, so I will usually be writing omega. If it is not clear if it is omega or capital W, I will write the units, so joule per kilogram. And lastly, we have some types of works. Type of work is mechanical, best branch, electrical, magnetic, and moving boundary. Moving boundary is the work that we will be looking at. It is called PTV work. Mechanical also has subcategories: shaft, like in an aeroplane turbine, displacement, and spring. So that's it for this lecture. After this, we'll be moving to the core of the chapter known as PDV work, and after that we're going to look at the tutorial for this chapter.